Welcome everybody. We are the MS in Architecture, Computational Technologies at New York Institute of Technology. And today we have our guest lecture series of the spring of 2022, Marcella and Signore. The lecture series aims to discuss research trained by invited guest speakers. The program focuses on architecture, expanding relationship between science, technology, and culture through innovation in algorithms, simulation, AI, robotics, robotic fabrications, and materials. The spring semester lecture series discusses alternative means to understand the dialectics between the digital ideal and the physical digital. Within an architecture of information, AI, robotics, and materials as well as actualization interfaces. This process understands the information flows and their actualizations as architecture. Today, we have the honor of having Marcella and Signore, who is going to be lecturing on ENTANGLED, Ecologies of the Public Realm. And Marcella, as you probably know, is a professor at the New York Institute of Technology, associate professor, and also the director of the Urban Design Program at NYIT School of Architecture and Design, and the principal of Xtopia. The lecture description is as follows. The exploration of the public domain is an important parameter to define how we live as collective and how we can rethink the fundamentals of living. The public realm is an expanded field where the deployment of collective ecologies is inheritable, connected to the social cultural production of space and forms of cohabitations of living systems. The talk addresses the intersection of technologies with the public social cultural realm through prototyping, material, and fabricated systems, data-driven protocols, and mediated environments. Starting from Aereo, an installation recently exhibited at the 17th Architecture Veni Biennale, a series of projects will be the vehicle to speculate on the current and future states of social technical apparatus, interlaced ecosystems, and planetary entanglement. Marcella Di Signore is an architect, urbanist, educator, scholar, and the principal of Xtopia, a design research practice that explores the intersection of architecture and urbanism with technology and the public, social, and cultural realm. As I said, she's the associate professor and director of the MS in Architectural Urban Design at New York Institute of Technology School of Architecture and Design. Her research focuses on interscalar design approaches that engages the notion of social, cultural, technical systems through computation, prototyping, material and fabricated assemblies, data-driven protocols, and adaptive materials environments. Her work investigates architecture environments and cities not as isolated entities, but as part of an extended field mediated through the discursive application of technology. She is the author of many books, actually. One of them, Urban Machines, Public Space, and in Digital Culture, and the editor of Data Matter Design book. In her practice, she has built a wide array of urban interventions and small-scale prototypes recognized through awards, grants, and publications. In 2018, she co-curated the Data Matter exhibition at the ECC during the 2018 Venice Architecture Biennale. And in 2021, she exhibited Aereo in the 17th Venice Architecture Biennale. Welcome, Marcella, and the room is yours.
Thank you. Thank you, Pablo, for the introduction, and thank you for the students for being there. So it's I'm excited. Hi, everyone. I'm excited to share the work and then be part of the discussion afterwards. So I will start with a quick framing in terms of how some of these terms have been operative in the way in which I've been working in the last years. And then I will present 4 projects that in a way relate to each other through the lens of the initial framework. So as Pablo said, I've always been interested in exploring the connection between architecture and urbanism, the relationship specifically, and the connection with technology, but also how this is connected to the public and social and cultural realm. I've been focused on interscalar approaches to design, so how we can begin to design and think through the continuity of interscalar design approaches from the small scale to the medium scale to the large and territorial scale, and really framing the work through socio-technical systems, through computation, prototyping, material and fabricated assemblies, but also data-driven protocols and adaptive environment. I really see, and you will see in some of these projects, so the project I will present are small scale, but try to expand on the notion of the continuum and understanding in particular architecture environments and cities, not as isolated entities, but really part of an extended field. And I've been working for the last, I would say, 10 plus years or more through these different platforms. So through teaching, through academia and research, design practice, but also curation and exhibition. So this has been my, let's say, parallel platform of work. And you will see that some of the projects that are presented, that some of the work integrate different ways in which these four layers are intertwined and connected within the production and the research. So the title of this lecture is Entangled Ecologies of the Public Realm. Over the last, I would say, 10 plus years, my main focus has been the notion of the public realm and the public of domain, really as a starting point to understand. I really see the public space and the public realm where a field where the public dynamics of society take place. And I think, you know, now more than ever, I think when we look at the public realm, it's really how this, the public domain, I think is more important than ever, especially for what happened in the last 2 years and what is happening now, but also an important ground to how we define, how we, you know, we live as a collective. And but also I think it's an opportunity for designers to really rethink our fundamentals of living. So the public realm and the public domain refers to the expanded sphere where individuals express themselves through a larger collective. Richard Sennett in particular argues that being public lies in the amount of knowledge that one person or group has about one another. In the public space, people can access unfamiliar knowledge, expanding the horizon of their information. This principle of cohabitation that can exist in the public realm doesn't mean that it's devoid of any friction. For instance, public-owned public spaces or spaces of non-inclusion. But on the contrary, this triggers the question of where and how that public domain has a possibility to emerge, to live and thrive. And also I'm interested again in this notion of really the expanded public domain and understanding that, for instance, sometimes the full potential of the public domain emerges in institutionalized civic spaces, but in other instances really exists at the edges, at the border, fragments of cities and in liminal spaces between zones. In Sennett's essay, it talks about, again, the public, he cites also Hannah Arendt, where the public realm is understood mostly in terms of politics. Instead of Jürgen Habermas, talks about the public realm is connected to economic interest. And versus Sennett really talks about that the public realm is less political and more cultural, therefore rooted in rituals. So these have been principles that I've tried to explore also through the project and really understanding again the public realm as a platform and as a background and as a context for some of the project. Also, the interest in the public realm has brought me to expand on the notion of socio-technical system. And the public realm, I believe, is one of the expanded fields where the deployment of a socio-technical system are inherently embedded. And a socio-technical system is understands social structure to develop the design of systems that involve people, technology, and their environment. It recognizes the inherent relationship between society's complex infrastructures and human behaviors. Socio-technical theory acknowledges the fact that we need to design, and I want to stress here the word design, both aspects together for a more holistic view. So society is not determined by technology, nor is technology determined by society, but both emerge as two sides of the socio-technical coin. The relationship between society and technology has existed, as we know, since the beginning of humankind. But the difference between the past and present is that the extent, I believe, of social binding. So the more social forces it binds together, the more powerful could be, maybe. So the social shaping of technology recognizes that technologies in general are the outcome of social action. So what is the social setting in which technology is deployed? Digital components such as software and data have spatial and social cultural life, I believe, in of themselves. we had to reflect on how what is called digital components engage with society at large and its form of practices. The relationship between code and space is both contingent and relational. So this work connecting somehow this is more like a background and more a context within which I've been working, especially for some of the projects that you will see. This also been framed through the books developed in the last years. The first one is Urban Machines, Public Space in a Digital Culture, that was published in 2018 and published again in 2020. Urban Machines, Public Space in a Digital Culture reflects on the connection between relational social systems and technology, framed in particular through the ICT, information and communication technologies, and how they affect the public realm. And through the develop of built urban, really through the lens of developed and built urban prototypes. And this is what I call urban machines, that engage information technology as a catalytic tool for expanding, augmenting, altering public and social interaction in the urban space. In more detail, so I want to first introduce this book because this has been a kind of a way in which, so the book actually took more than 10 years to be written. And this has been, I started working on this in 2012, and this book has evolved. Actually, I'm currently working on the second edition, because as you know, things get obsolete quickly. And so this book has been a kind of underlying framework for some of the projects, and especially the urban build prototype developed in the last year. And the book really reflects on the public realm and the relationship between ICT through three main layers. So essay, case studies, and conversation. And in the essay, there is a reflection of how the public realm and ICT are connected through operational framework, looking at interacting, integrating, expanding, hacking, and networking as 5 categories that investigate how ICT affect the public realm. The case studies represent mostly an historical overview of selected projects that can be considered within this framework, urban machines, for the capacity to catalyze relationship between city, citizens, place, technology through feedback mechanism. And the third one is the conversation that expand on particular topics, looking at situated technology, data, participation, network, scenario planning, and open source city. And as framed in the book, and this is also give you a little bit of the understanding of some of the projects that I will present, urban machines can be an accelerator of multiple operation in the urban environment. So the generative potential of this intervention have the capacity to catalyze processes of co-creation of the open city. So a city that is in constant evolution, but looking mostly at the synergy between bottom up and top down. So they intervene in the public realm as a system that are socially, technologically, and physically integrated. Environment, spaces, technology at the different level are intertwined to produce a space that encourage new modes of urbanity for the public domain and the emergence specifically of new forms of public life. Through this, my work has been looking at, this is a book published last year by Routledge, and actually Professor Lorenzo Roa has a chapter in it within the first chapter, which is data and urban systems. And this book is, I see this as also as an extension of some of the work done within the Urban Machines book. And also here looking specifically to expand on the role of technology, space, and society, reflecting on the role of data in the urban environment, and looking between the relationship with the data science and urban systems. So you will see some of these projects also intertwined and connected to some of the content of the lecture. So these are really the three main focus, the focus somehow that has been a kind of framework for the work, from the work in the last year. So the public realm and domain, socio-technical systems, but also urbanity. So I'm particularly interested in this notion of urbanity that goes beyond what we can design urbanization of urban system, and particularly how does the notion of urbanity has changed. And when we know, then we talk about urbanity is completely different than what we call about, urban system, but urbanity puts people at the center and really start to understand socio-technical system or social dynamics from from the perspective of how we shape urban environments specifically. And in particular, how digital technology could help to intensify interaction between urban space, people, everyday objects, architecture, media devices, and urban network to promote urbanity. So these four categories are, so the four projects that I will present are framed through these lenses, four lenses: transcode, network, inform, and embody. The small scale design projects that will be presented are small scale, but try to test and prototype larger relationships that often are at the architectural scale, urban design, or territorial scale. And looking in particular, again, public realm, socio-technical system, and how the two are connected. All the projects share three parameters. So there are three main parameters that are shared from the three projects that were presented. So the socio-technical encoding as the protocol employed, the spatial instrumentation as device or set of devices that are employed, but also the deployment as strategies to reach both local and diffuse condition. And this is when I talk specifically about the interscalar condition of some of these projects, that even though constructed at small scale, have the capacity to impact larger urban systems. So the first project, Urban Syncopation, this is a project commissioned by the Nuit Blanche and exhibited at the Gardiner Museum in Toronto in 2016. And the project explored the notion of transcoding as a socio-technical act. Transcoding here is a simple term as the act, as we know, to convert language or information from one form of coded representation to another. Urban syncopation is a performative topography and facade prototype that inhabits the city and functions as an infrastructural device that collects, transcodes, and retransmits the collective heartbeat of the city. So the project explored here in particular the public domain, again, and data through audio and sensorial data to register public life and ultimately urbanity in downtown Toronto. The web of sonorous and visual sensory data is meant to perform through the surface itself as an abstract index of urban life and collective living, an experiential datascape of the diversity, complexity, and temporality of the urban conditions. The project embraces material behavior and performance as a means to derive the overall form. Each strata is defined through a series of faceted mirror and perforated pixels or modules to generate a vertical topographical pattern. The variation as the lateral compression and expansion of the folded surface emphasize the way in which information is redeployed across the surface, capturing and rendering visible sound data drawn from the urban environment. So for this project, we worked for about 6 months with different community organizations in downtown Toronto to work on really the condition of urbanity on some of the areas in downtown Toronto. So each pixel is constructed as a flat surface to then be folded to achieve a three-dimensional configuration. So here you can see the fabrication phase. We work with the CNC and a local bond in order to basically construct first each pixel that had also different type of scalar variation as a two-dimensional surface, and then activate the three-dimensional configurability through folding. So these volumetric pixels operate as a stabilizing building blocks of the wall system. So here you see the installation phase in the museum, at the Gardiner Museum in Toronto, and how this again was constructed as a, to really achieve stability, but also was constructed as, again, these 5 strata and as building blocks of the facade prototype. Each strata, as you can see here, so the media responsive strategy is associated with a street in downtown Toronto and receives data from each of the locations. The wall system references the layered streets, urban grid, and shifting topography that constitutes the fabric of the city, while at the same time extract sensory information drawn from the city's public space. Sound sensors track urban activity levels through the day and night and translate this data into a rhythmic series of pulsating input and extracted data graph. So you can see some of these images here. The collected soundscape was transcoded and processed to extract the amplitude of each sound and sequenced as an array of corresponding input in each of the horizontal strata. So each strata connected directly with one street in downtown Toronto. So here the city is understood simultaneously as material and performative, a physical artifact, as well as an infrastructure or stage for more ephemeral activities and events of urban life to take place. The sensorial condition of urbanity are captured in the piece in two distinct ways. One is material and the other is performative. Material, as a result of its materiality and geometry, in its immediate presence, the surface reflects and refracts and fragments the surrounding space and motion of visitors who become both actors and audience in space. So this is the piece during the day, very different, but also performative. This direct form of material feedback is then augmented by a second performative layer. Urban sound data is recorded and transcoded into the streaming flow of syncopated bands of pulsating light. Sound sensors located along the street in downtown Toronto are employed to retrieve 12 hours of sound data to track proximate and distant urban activity levels throughout the day and night. Since sounds occur more in time than in space, each track of sound data collected was spatially embedded as a linear sequence and visualized on screen as a video, a running barcode that encoded the rhythm, frequency, and intensity of the oral inputs. This barcode mediates between the oral and visual realms by converting both the sensorial materials into a codified string of data. So the project really explored this form of rematerialization of the sensorial city. And the 6 layers that you saw stream continuously pulsating inputs where each rhythm refers back to the sound of the streetscape, producing a syncopated effect that renders visible the ephemeral events of urbanity. In the project, the socio-technical act of transcoding operates as a translator between the material and the sensorial realm. It is a mediator across bodily architecture and urban protocols that means by which the sensorial and the experiential city is condensed and rematerialized. So here you can see also how the piece had an urban presence. So we, of course, the piece was designed specifically for the event, and it worked really basically as an immediate environment within the museum, but also as an urban facade on the exterior. The second project, again, the work still within the same framework is Data Field. This is a project supported by the Arts Council of New Orleans, and this project actually started in 2016 and is still going on. And so we submitted an RFP, and we got we won the competition basically. And this project was part of the strategy. So I lived in New Orleans for about 10 years, and I was part of the reconstruction after Katrina. And this project was part of the new master plan developed along one of the main canals in New Orleans. And the city basically asked, how can we develop a placemaking intervention that deals with water and connects citizens across the different parts of the city, but also really looking at the south of the United States, the Gulf Coast specifically. So this project explored the notion of informing as a socio-technical act. Here, informing is intended as the act of giving form and life through information influences. The project explored, again, the public domain through data implemented to systemic and relational approaches. And in this project specifically, we looked at how data implemented through systemic approaches can be a powerful tool to design in soft land, so in vulnerable ecosystem, especially in the southern part of the United States, and strengthen citizen awareness. Through sensing and actuating technology and the visualization here of the hidden data streams, active citizen participation is enabled, becoming agents able to understand and act upon the complex water ecology and hidden infrastructural network of the city of New Orleans. So the project is part of the city strategies to show how cities can live with water within the context of rebuilding infrastructure to the lens of resiliency. So the project specifically makes a connection between the city's topography and its intricate water infrastructural network essential for the existence of the city itself. So as you might know, New Orleans is built, most of the city is built below water level. And in order for the city to function, there is a network of pumping stations that basically needs to be active 24 hours in order to keep the city dry. and pump the water out of the city itself. And this project is building on that, and in particular, a network of macro and micro points establish the relationship between the pumping station, in this case, and their respective capacity. Linking these points to the sectional, so here you see the generative process, the sectional representation of the topography. The project becomes a responsive and inhabitable three-dimensional map of the city water infrastructure, while acting as a placemaking machine along one of the main water canals in the city of New Orleans. The gradient from light to dark blue poles show the inverted topography of the city and how data begin to inform matter in its manifestation. The macro poles are placed in direct conjunction with the pumping station location, responding to real-time data of water capacity of the city's pumping station. The layer apparatus allow for the cohabitation of people, communities in constant mutation of informed phenomena. So in particularly, again, this project really tried to develop a placemaking intervention, but also creating awareness around the water issues or the water capacities in the city of New Orleans. The large macro poles record frequency and intensity of pumping activity at several New Orleans pumping stations, referencing real-time data and translating to signal and text. Working with technology-mediated narratives, the work so really is looking at this notion from the individual to the collective. The hyper-mediated environment is generated by a range of data related to water dynamics, rendering a reality in constant mutation. Data field is designed, again, to raise awareness of water network of the city of New Orleans, making it visible and draw community towards water-related issues. And most importantly, this is why this project was developed. The project aimed to establish a platform for citizens, not only a placemaking intervention, but a platform for citizens to share and communicate the challenges and opportunities that New Orleans faces in living with water. As you can see, this is the first prototyping on one of the sections. This project has been, let's say, in progress for a long time. We tested the large-scale prototype. This is just one of the small section of the entire space. And also, while we were waiting for the full-scale implementation, a small-scale prototype was built to continue to raise awareness of water-related issues connected to accessible data and network phenomena. So this project was developed, a small-scale version of the full-scale project was developed about 3 years ago for one of the events in New Orleans called LunaFest. And here you can see that actually this a very small scale prototype was instrumental to understand the functioning at the macro scale of the city. And this was developed again for a short event, looking again at generating the scale map of the city and each pole corresponding to pumping station and live feed data, registering in this case water fluctuation. So you can see here the different type of location of the pumping stations and the water capacity. And so this prototype, small scales, this is small scale that's different than the large scale implementation, was really developed to continue to bring awareness through again, looking at water and resiliency and soft land, and really create somehow a node for the large scale implementation. So here you see a little bit of how the project was generated. And this is the entire city of New Orleans looking at, again, this network of pumping station and how the full scale intervention will be along one of these canals. And so this project had a lot of back and forth, but we were able to really continue the discussion and continue to work on this project for the last 5 years. And also this project somehow triggered the development of the Data Matter exhibition in 2018. And in particular, this project was included in the exhibition. And the exhibition featured 12 practices and title in the exhibition Data and Matter. And here you can see how, again, from the project, there was an extension within exhibition and curation of this exhibition, and then the exhibition basically became part of the book, and Pablo was also part of that. And so this was a very interesting, also as a way to, again, create a framework around a group of projects that use emerging and novel forms of reading and produce spatial conditions to connect visualized data, responsive systems, sensing, actuating technology through both micro and macro scale. So here you can see some images of the exhibition in Venice in 2018. So you can see here a little bit, from a project to a curation of an exhibition to then the publication of the book last year. The next project actually is a project developed more in a academic environment, and this is I directed for 3 years the Global Summer School for IAC in Barcelona. So I was the director of the New York program, and I was director for 3 years from 2014 to 2017. And every year we worked on a different project, small scale intervention developed really in 2-3 weeks. And this project was developed at the Brooklyn Navy Yard and in collaboration with Terraform. And so this project also explored the public domain through the body as a socio-technical apparatus, and here the presence of body biometrics in the public realm. One question that we were exploring here is how does the body relate to the public space, a sensing mechanism, a relational device, and how this has changed over time. Biometric technology, for instance, that's one main thing that we were exploring. And again, the relationship, the public domain and the body as a socio-technical apparatus. You'll understand this better in a second. So the project investigates how the environment in which we live affects the body. In particular, explore the dynamic relationship between the scale of the macro or environment and micro of the body through 4 sites in New York City. The framework explore was how the notion of social ecology intended as an interaction between the social and environmental systems. In particular, the relationship between the environment and context and the body of biometrics to understand how the city is experienced and how the environments affect the body through feedback loops and responsive mechanisms. We chose 4 prototypical sites in New York, and we worked basically in 4 different sites that had very different type of urban conditions: the Brooklyn Bridge, Washington Square Park, the Grand Central, and Top of the Rock. And the project engaged simultaneously 2 sets of data and sensing devices. So the environmental sensor looking at sound, light, temperature, humidity, and CO2, and then the correlation with body sensor, heart rate, stress sensor, and skin conductance. The first step of this phase was to build the data acquisition unit as a portable device able to be attached to the body to record the story real-time, the data sets, each of the 4 sites. The customized sensing device incorporated simultaneously biometric and environmental sensors to understand the level and degree of codependence of data sets and how they affect each other in relation to the context. So we walked, basically, this is the trajectory through the 4 sites. Through evaluation and comparative process, pattern of reciprocal data behavior started to emerge. So this was built before we started the summer school. And was built at IAC in Barcelona. And here you can see the data acquisition unit in different locations, measuring biometrics and environmental data simultaneously. So we literally walked through the site, and these four sites with extreme, different conditions. This is Top of the Rock, measuring biometrics. And so the data were then stored in real time, and we started to generate average values. And then and we started basically to see information and relationship, really, of codependency between the body, the biometrics data and the environmental data. From that, basically, we started to develop the geometry, and we work in this case with numeric structure. Made of, in this case, of this again was a project really developed in 2-3 weeks, but it was quite intense, and it was really kind of a testing prototype of understanding really this type of relationship. So the geometry in this case was first tested into small prototype units to understand the inflation capacity relative to structural performance. Here you see the piece deflated, and then deflated the macro component again. And then a series of nonlinear testing were performed to evaluate, again, the relationship between air supply, the system of interconnected inflation tubes, and the form finding process. So once the stable form was achieved, the system was aggregated in its final configuration and ready to receive biometric real-time responsive mechanism. So you can see here all the testing, and the last phase was to plug in the physiological responsive units. Each individual spatial responsive unit was assembled into a macro spatial map that was layered with the embedded biometric sensor to provide real-time responses and feedback. So the first unit, which was looking at Grand Central, sensing real-time the heart rate. The second one, Top of the Rock, sensing real-time CO2 in the breath. And the third one, Brooklyn Bridge, sensing real-time the skin conductance. So here you see how somehow the machine works in relation to when it was installed physically at the Brooklyn Navy Yard. And here are the sectional condition. So users were able to plug in into the physical prototype, reading various biometric data, providing actuated feedback through breathing, inflation and deflation, but also having the response of, in this case, pulsating lighting effects. These are the 3 units aggregated and the real-time display of data. So this project, again, was short, but was important, let's say, to structure also some of the narrative that were developed during the 3 years where I worked at IAC as a program director for the Global Summer School. So the testing of those interdependent actuated conditions can be the accelerator in ways we understand urban space and its multiple form of operation. And so really looking at the relationship between individual and the collective, and how the body can be understood as a site and how mutually influence each other. So I'll go a little faster here. And so you see when user interact and the real-time response, and then this is the final configuration. So this, again, as I said, is a short project, but it was quite important in terms of setting up the process of some of this, and then this emerged then into future work. So the last project I want to show is the project that I'm currently still working on. This project was selected and was exhibited in 2021 at the Venice Biennale, and it was part of the Italian pavilion and was part of the Resilient Community section, Architecture as Caregiver. So this project really started from the notion of how breathing is a vital activity to sustain life and act as an interface between the environment and ourselves. Collective ecologies of breathing practices are inherently connected to the social cultural production of space and the health and adaptability of living system. So the project really links 3 main forms of inquiry: the public realm, the socio-technical system, and public health. So we focusing in particular at air pollution, air data, but also CO2 presence, CO2 present in urban environments, and CO2 absorption. So we started first looking at air pollution in general as a kind of global phenomena, mapping and looking at the data globally, global air quality and effects on health. So this was really the beginning of the research, looking at gas emissions as well, and also air pollution and the impact of long-term air pollution on a person's health. Considering, for instance, that every additional 10 milligrams per cubic meter of PM10 reduced the life expectancy of a person of 0.6 years. So first, we really started to construct the kind of framework, looking at also the potential change in life expectancy over time. So, for instance, Michael Greenstone, the director of the EPIC, explained that basically the impact of pollutants in the air, it's comparable somehow someone smoking cigarette for several decades, and really depends on the type of particles. So Aereo was really developed with the idea of generating a soft machine conceived as a macro breathing organ that explores formal cohabitation of species through the ecology of breathing and investigates health as a public value. And as I mentioned, really the project tried to link three main fields of inquiry: the public realm, the socio-technical system, and health. Aereo, again, is a prototype for public space that acts as a device that can relayer urban surfaces to provide a scenario of codependency of living systems. By mapping prototypical public spaces, the project aims to predict scenario of dynamic absorption of CO2 in the public realm by interpolating data relative to material technology, human occupation, density, and surrounding air ecologies. So we started basically looking at the scenarios of dynamic absorption. You will understand better the specific material technology that we use. But we work basically in three cities: New York City, Barcelona, Rio de Janeiro, and understanding basically the relationship between public space occupancy and CO2. Here we worked with a group from Barcelona that looked at spatial analytics in the way in which the project was developed for the initial data analysis. But also the project is strongly connected to, let's say, the macro scale and the material scale. So the macro breathing organ in this case, so the project really acts as a cleaning, filtering, processing air device through the performative textile material embedded into the woven surface. So the project, as you saw it, so basically as a hard and soft surface. So the hard surface was basically connecting to the red thread that you saw. And the red thread was developed to embed an advanced polymer integrating ViewPureTech. So ViewPureTech, it's a material that is patent in Spain, actually, that was developed, and this is what we were collaborating with. It was patent in the University of Valencia. And ViewPureTech, it's 100% natural mineral compound that has the property to mineralize primary greenhouse gases polluting the air we breathe. And it can absorb and naturalize CO2, NOx, and VOS, converting them into active material. So the project really connected two things. So the prototype, but also here what you see, what we call air ecologies machine, that was able to track basically in real time the material performance at the micro scale, visualizing the quantity of CO2 absorbed, ppm, correlated to the humidity value. And so the machine was basically installed at the Venice Biennale for 6 months, the entire time of the exhibition, and we really used it as a testing, was able to look at how the material performed in real time during the 6 months. So at the macro scale component, here you can see the material technology, the air ecologies machine tracks in real time, the material performance, as I said, of the macro scale. And the visualization of data produced aims to generate and increase collective awareness of, again, the interconnectedness between the micro and the macro scale. So we literally use the powder that you see here that was woven and connected within the thread of the surface. So we worked with recursive system to basically develop a surface that increase surface capacity. So here you see how the relationship between the hard and the soft. But also the idea was to work on this incremental dynamic absorption from again the soft piece that was embedded within the hard piece. And here you see again the idea of how the soft part, so the thread was connected directly with the hard. And working in particular to increase surface condition. So the hard base and the performative soft thread. So the fabrication process, so I collaborated with a group of fabricators actually in Barcelona, and the fabrication process. So we used 3D printed wasp technology. We worked on optimizing. The project was literally divided into smaller pieces, and then they were aggregated. And here you can see the fabrication itself, but also you see how we work mostly with PLA, white and translucent, in order to give the variation between the white hard piece and the translucent part, able to reflect the light from behind. And then here you see how basically the steps of the modules and assembly that were then aggregated into these macro modules and connected directly with the soft part. The assembly, here you see the project at the Venice Biennale. So this was shipped into 6 modules and then macro modules, and then assembled on site. And this is the entire exhibition in Venice, and linking again the 3 pieces. So the micro scale through the ECOLOGIES machine, the surface, and then the way in which these were related directly to the study that we did in the 3 cities. So here you can see the piece. So this project is still it's been now dismantled from the Venice Biennale, and it will be actually stored in a permanent museum as a permanent collection in Italy. But the project is still continues to. I'm still working on it to see how this can be developed at a much larger scale. So these are some of the images in Venice. And we learn a lot, I have to say, from the fabrication and to the process. So maybe, not that I will do it in a different way, but I think there is a lot of work in terms of the feedback and the optimization of the way in which the project was developed. And here you see, let's see if you're able to see the video. So that this tells a little bit of the narrative behind the project itself. And how this was developed. So this was the actual video that was projected in Venice. Okay, I don't know, I think it was stuck. Let me see here. Just want to show you maybe the last part. And I think you can see it. Yes. 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 And so the material that we use, basically this powder, it's part of a volcanic material that, as I said, has been patented in the University of Valencia, and it's also being used right now for the fashion industry specifically. And the idea is to also continue the project at that level in terms of using this specific material technology. And this was during the fabrication piece. Okay, thank you very much, everyone.
Thank you.
I went a little bit longer, I think.
Oh, it was perfect. Thank you so much, Marcella.
Thank you.
Great work. I just want maybe a comment, and then I'm sure the students have some questions.
Yes, of course.
So it was very interesting to see the relationship between data and the social, the way that you put it, right? As a collective environment, right? Like a collective of social actors in relationship to environmental conditions, right? How your work is trying to develop an interface to measure and then feedback those relationships. So it's very interesting, very well explained, the lecture, and very interesting type of work. So congratulations. It just was very nice to see it all together, because we never
see each other's work.
right? We work every day together, and we actually, we work in a lot of projects and publications, but we never have the opportunity to have this kind of exchange. So it was very nice to see the work together. So congratulations. So I don't know if you guys have any questions, Salma, Farah, any comments, questions? Yusuf. And I see that there's also Maria here, Maria Claudia Coppola. I don't know if has a question.
I have a question. It's regarding the incremental growth. So is it like proportional to the CO2 levels, or how did that, I mean, how did y'all decide upon it?
Yes, so I have to say, you know, this project had a lot of I worked more than a year on this project. So the one idea of using recursive system is that we were working specifically of how within the hard surface we could increase surface area in order to embed the specific, you know, the powder that the wear pure tech material on a much larger scale. And that was the idea of particularly working with the incremental growth of scaling and scaling this type of parts. So working with density, working with incremental growth, but also working with increasing surface area. That was really the logic. And so this project, so the material that I mentioned, it's a material actually that was tested first into wearable objects. And it was first patent and then was tested on clothing. And then with the collaboration of this company that we work with in Spain, Numena, we took exactly the material and we tested at the scale, looking through the kind of textile performance of the thread that was used. But the idea is to continue to work on this project, to continue to work on this type of material, and also increase scale.
Okay, thank you.
Any questions? Farah?
I would like to ask, when interpolating data into a geometry, what could be the parameters behind the design process?
That was Marcella. She got maybe she logs in back in. Let's wait probably the internet. Let's wait for a couple of minutes.
Hello?
Yes, we lost you.
You know, Zoom kicked me out. I don't know, all of a sudden disappeared.
Maybe the time, I don't know.
I don't know, it's just blank.
Yeah,
so I don't know.
Right. So Farah has here a question.
Yes.
I was wondering what could inform the design process when one is interpolating data into a geometry or a form?
Again? She doesn't like the book. It's a good question for you. I'm glad that you're asking. Maybe she can log in with herself.
I don't know if it's my Zoom.
Yeah, maybe some glitch. Did you hear the question?
I had an issue with, I think it's my Zoom account. That's even here, I don't know. Sorry.
Did you hear the question, or should we?
I didn't.
Ah.
I was wondering, what could inform the design process when one is interpolating data into a geometry or a form, the parameters, or what could inform the design process?
Yeah, so for instance, in the project, just to give you an example, I think maybe you refer to the third project, the one from AYAC. So when we looked in the case specifically the interpolation of environmental data, and then the data that we collected through the body sensor. So we were looking at basically correlation of them, in a sense that when, for instance, there were certain type of environmental conditions, maybe the heart rate or the skin conductance increase or decrease, etc. So we were trying basically, in terms of the geometry, we were trying to translate directly this type of, it was more as an idea of really, both projects really look at this idea of map somehow, of how the geometry becomes an inhabitable map of those type of conditions. So that was the idea. And the same thing was for the New Orleans project that, as I said, is still ongoing, but particularly looked at the way in which the geometry there was, you saw probably in the video, was developed, is that we looked at this network of pumping station, and then topography. The topography was reversed to go from the below zero to the above, and then was really the spatial infrastructure in order to then plug in the real-time data of the water capacities. So I think, depending on the project, the process is different. So in some cases it's more generative. In some other cases it's just the geometry or the space I see it mostly as an infrastructure to then other things to be layered on. So yes, can you see me well now?
Yes.
Okay.
All right. Okay, so it's already 3:10, so we extended a little bit of the time, but thank you, Marcella, so much for your presentation and for the work, and congratulations. Really nice and refreshing to see the work and what you're working on. So
thank you. So I hope to see you guys in person soon. I'm on the 11th floor.
yes, exactly. So, well, you're coming to the midterm. You're coming to the midterm review, right?
That's March 29th. Yeah. 31, that's right. I have it on the calendar. So good to see you. I look forward to seeing your work and for future exchange.